35. We'll give this a whirl. And is it hard? It's on this page. All right, all right. Whoa, lost it. This isn't going to be good. Up. Oh, there we go. A right triangle. A right triangle has area 30 square feet. And the hypotenuse has 1 foot longer than one of the sides. Okay, we can do that. There we go. Right triangle, hypotenuse, h, base, height, right angle. Area equals base times the height, 1/2 of that, right? You got that far, didn't you? I'm sure.
Yep.
All right. Well, so which side did you pick to be 1 foot longer, the B or the H? All right, B, +1. There, hypotenuse is 1 foot longer than one of its sides. It doesn't say a special side, just one of them. All right, 30 right here, isn't it? A equals 30. So I have 30 equals 1/2 base times the height. My solution is going to come from this equation right here, because this is the only one that has a number in it. My substitution is going to come from right up here. What's Pythagorean theorem, Brooke? Hi. Pythagorean theorem is what? Pythagorean theorem? Yeah, well, I don't have A's, B's, and C's, so what is it? H squared plus what? Right, equals? Yeah, that would be an H for the hypotenuse. H squared. In place of that, I can put in B +1. See, I'm narrowing it down. So far, so good? All right. So H squared equals B +1 squared minus B squared. Holy cow. Is this right? Skipped it? Oh, look at this. 60 equals BH, right? I didn't read the first question. The first question doesn't want a solution, it wants the equation. Ah, that's a piece of cake. Yeah, moving on. Well, take a look at this. H equals 60 divided by B, doesn't it? Okay. That H and that H are the same. Ta-da! Ta-da! So I have 60 over B squared equals B +1 squared minus B squared. What am I trying to get to? No, the equation. It says show that it's true. Does the equation have a denominator with B squared in it? No. Multiply everything by B squared. Well, actually, these go away, don't they? Those go away, right? Now multiply everything by B squared, and you get 3,600 equals 2B cubed plus B squared. Is that pretty close to the equation? That's real close. All I got to do is take the 3,600 over there. 0 equals 2B cubed plus B squared minus 3,600. Somebody second hour, taking a snooze, they woke up when I got to this point, they go, it's supposed to be X's. I go, change the B's to X's and you'll be fine. Not a problem. You can do that. Isn't that right? Did you have fun writing all that down? Did you write down any of it? Excellent. How do we solve it? I mean, yeah. Graph. Did you graph it? No. We got graph? I'll race you. Oh, don't sigh like that. I know you don't want to, but you have to. That's why you're here, isn't it? To learn. People in college now, that's a little different. Oh, last night was unbelievable. It was just, I'm on the mic. 2B cubed 2 x caret 3 plus x squared minus 3,600. Now, I'm not going to go all the way out to 3,600 on my window. I don't know, I'll go out to like 200. I'll start there. Not negative 200. The x can't be a negative length. So I'll just go from 0, delete, to 200. I'll start there first. Scale 10. See what we got. Graph it out. Booyah! Oh, there's a hit. That's good enough for me. Error, we'll fix it. Second, calculate 0, 0 to 5. I don't know what that number is. What did I go by scale by?
10.
All right, so I'll go 20, and then I'll go 10 for my guess. So the answer is, 12. That's nice. So I got 12. Did you get 12, Brooke?
Yep.
Good. Now what do we do next? What do you mean you don't know? No, you don't do synthetic division. It says shows a positive root. Check. You remember? You can show it this way. F of 12 equals 0. Check. That's the factor theorem. Then find the lengths and the sides of the triangle. All right, so B is 12. The hypotenuse was one further, right? 13. And this was 5. Nice. 5, 12, 13. Very good, don't you think? Excellent. Huh? Who's over here? Beamer. Man. All right. We are moving on. We're moving on.
He's on the microphone.
Rational functions. Oh, this is going to be fun. I am. Rational functions. Thomas, what is a rational function? What's rational number? Fraction. Very good. So a rational function is something like, I don't know, f of x equals, you'll have a numerator, I'll call it capital N over x, and denominator, I'll call it capital D over x. You have a numerator divided by a denominator. There are lots of things going on with that graph. Lots of things. First of all, there's a little checklist when you sketch a graph. You're going to have to sketch this graph. When you sketch it, well, the first thing is, what's the domain? Because we have issues anytime you have a denominator, correct? Why do we have issues with the denominator? No. Take your calculator and punch out 7 divided by 0. What do you get? Can't do that. You get an error. So any x value that makes d of x equals 0 is either going to be a vertical asymptote or it's either going to be a hole in the graph. This morning when I was going through this lesson, some people were not paying attention. They asked me to go back. I said, you got to be kidding me. I'm giving you my best right now. This is as good as it gets. There's no going back. If it makes the denominator equal to 0, there's two choices. One, it's going to equal a vertical asymptote, or two, it's going to go hole in the graph. You already know the denominator equals 0 because you looked there. How do you tell the difference? You put the x back in, and if you have a number over 0, it's a vertical asymptote. If you have 0 over 0, that's a hole in the graph. That's how you tell. Checklist number 1, complete. That all comes from d of x, and d stands for the denominator. Next, on your little checklist, horizontal or oblique asymptotes. I think I'll break this up into 2 days. Oblique asymptotes, we'll talk about tomorrow. Horizontal asymptotes, we'll talk about today. At the numerator, you remember all polynomials, they have a, what do all polynomials have? They have what? Exponents, positive exponents. We call those exponents what of the polynomial? The degree. All right? So the degree of the numerator is less than the degree of the denominator. Automatically, horizontal asymptote at y equals 0. No question about it. Automatically, horizontal asymptote at y equals 0. If the numerator, the degree of the numerator, less than the degree of the denominator. Got that? We're not going to talk about obliques today. We'll talk about those tomorrow, if there's time. So, what's another possibility between the degrees? If it's less than, we know what to do. What's another relationship between the two it could have? Equal to. If the degree of the numerator is equal to the degree of the denominator, automatically horizontal asymptote at y equals the numerator's leading coefficient divided by the denominator's leading coefficient. They won't be the same. The coefficient is the big number out in front. The degree is a small number to the variable. That's second on our checklist things to do. Third on our checklist, this is all for rational functions. Tomorrow in calculus, they're going to get 20 minutes, one question. That one question is, sketch this graph. They have on their checklist 8 things. You have 4 things. Why the difference? One's in pre-calculus, the other's in calculus. There's a difference. What else can you do? Oh, you'd be surprised. The other thing on your checklist is the x-intercept. How do you tell where the x-intercept is? Right, where it crosses the graph and where the numerator equals 0. Use the denominator for the domain, the numerator for the x-intercepts. So far, so good? Must be a review for a few of you not writing things down. That's okay. I will call on you in a moment. Y-intercepts. That's 4th thing to do on your checklist. What is the y-intercept? How do you find those? Yeah. You put 0 in for x. And you see what y equals. And you obviously have a graphing calculator to help you. But you won't be able to read the graph unless you know these 4 things. All right? I think we're, oh, did I put a check box? There we go. I think we're ready, don't you? Why? Because when you make a grocery list, when you get something, you could be the type of person that would make a scratch through all that, or check means you got it. 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 Do you make a grocery list yet? You will when you get older, because you'll forget things. And then are you the type that's going to scratch it out or just check it off? That's what I did. I don't know how many former students I've seen at the IGA just stand there. Forgot to make your list, eh? Yes, Mr. Barry. Nice. Oh, we're not doing that. We're not doing that either. Hey, get the door, Courtney. Let her in if you want. You don't have to. It's up to you. No. Quiet. We're busy. Who? All right. Just a minute. Quiet, please. What is the domain? Miss Suits. What's the domain? We did. Oh my. No. What's the domain of this one? Where do you look at for the domain? Where's that? The denominator. What makes it equal to 0? Zero. Yeah. So the domain x can't equal 0. Why? You can't divide by 0. You get an error on the calculator. So what is the function value of 0 going to be? 1 over 0. Is that a vertical asymptote or is that a hole in the graph? That is a vertical asymptote. So this has a vertical asymptote at x equals 0. Fantastic. That's the first thing on our checklist. The second thing, horizontal or oblique. It's got to be horizontal because we haven't talked about oblique yet. What is the degree of the numerator? It's 0. Anytime you have a constant, x is a 0 power. So the numerator degree is less than the denominator degree. That means horizontal asymptote, where? Y equals 0. Fantastic. Check, check. Next, what is the x-intercept? What makes the numerator equal to 0? Nothing. There isn't one. Y-intercept. Oh, check. Y-intercept. What do you get when you put 0 in for x? Error. So there isn't one. And now you make your sketch. Vertical asymptotes cannot be crossed. They get a dotted line. Horizontal asymptotes may or may not be crossed. Depends on the function. They also get a dotted line. Now you have to fill in the sketch. The horizontal asymptote is known as the end behavior of the graph. So I know at the far left and the far right, the graph is going to be going down to the x-axis. In the middle of the graph, around the y-axis, I know it's going to be going up or down. How do you tell which one it is? You can plug in numbers. Like negative 10 is going to be positive, isn't it? If you put negative 10 into the equation, that's going to be positive. So that means out here, y is going to be positive. Can it cross the x-axis? No, so it's going to bend up like that. All right, what happens if I put in 10? Still positive. In fact, that's known as an even function because what type of symmetry does it have? That's not the x-axis. Y-axis symmetry. It's an even function. Put it on your calculator. Go to y equals, press 1 divided by x squared, zoom 6, get yourself a look. Now you know exactly what's going on. You can't find horizontal asymptotes. You have to calculate them. You can kind of see verticals, but you still need to calculate those. X-intercepts, you have to calculate those. Y-intercepts, you have to calculate those. Any questions on that? You don't know. It's not called a parabola. You know it's not going to cross any of the axes. There is no x and y intercepts. And if I put a test point in, y is positive in both cases. So the graph has to stay above the x-axis. Okay? We're going to do another one. Ready for another one? Yeah. You're supposed to put in y equals 1 divided by x squared. Okay? Then go zoom 6. All right. I can try a brain break. I got a new one. I tried it in 6th hour. I got to find it first. There it is. All right. You need a You need a partner for this. Go ahead and stand up. We're going to do the hand slap. All right. So remember on the hand slap, quiet please. On the hand slap, you go 1, 2, and you cross the midline. And the other person goes 3, 4 on the way up, right? Now, in the other hand slap, you can do 1 or 2 numbers. This one you have to do 2. And you're trying to count from 1 to 40, okay? Now, in that count, you say the word biz for every multiple or 5, or if it has a 5 in it, okay? So it'd be like 5, 10, 15, 20. You get the idea? You say, when it comes up for you to count, you say biz instead of that number. Then, for every multiple or 7, or every number that has a 7 in it, you say buzz. Okay? Huh? Biz buzz is if the number has both a multiple of 5 and a multiple of 7 in it. All right. So the first person says 1. They go 1, then 2. The next one goes 3, then 4. The next one goes biz, 6. The next one goes buzz, and 7. You get the idea. Yeah. Now the idea of the game is you have to be the one group that does it correctly all the way to the end of 40. Some groups can't do it for some reason. They can't function. So, yeah. Yeah, you say biz or buzz in place of the numbers. Okay? All right, here we go. Ready? Go ahead. Do 2 numbers at a time. Do 2 numbers at a time. There you go. But it has a 7 in it. Keep going. All right, keep going. All right, nice job. Keep going if you're not quite done. All right.
Are we done?
I think so. Too complicated? Nice job, Marissa and Courtney. All right, have a seat. Anyway, so you're saying biz for numbers 5, 10, 15, 20, 25, 30, biz buzz for 35. Then for 14 or 7, 14, 17, 21, 27. Well, yeah, because it has 7 in it. Every number has 7 in it. So then you're saying for 27, biz buzz for 35, buzz for 7, things like that.
Wait, so would you say like 20 buzz?
20, then you would say buzz. 20 on one slap and buzz on the other one. Oh, yeah. Okay. Oh, yeah. So then for 20, you would say biz. I see what you're saying. Then for 21, you say buzz. Okay. So, yeah, it's kind of weird to watch some of the groups go. They go real slow. 11, and they're thinking 12. So, yeah, it's kind of fun. All right. Back to the rational algebraic functions in our... Here we go. So this one's already factored for us. Isn't that great? A little brain break, get a little refreshed. Back to the rational algebraic function world. This one only asks for the vertical, horizontal, and the holes in the graph. And also, remember, your checklist is only 4 squares long. It's not that bad. It doubles for some of you next year. For some. Huh? No, this asks, yeah, it asks for 2 of them. Vertical, horizontal, and holes. Okay? So first of all, I don't know, I'd approach it the same way. What's the domain of this function? X can't equal what? Yeah, x can't equal -2 or 1. So what's the function value of -2 if you put it in the equation? Yeah, you get 0 over 0, don't you? All right. And what's the function value of 1? Let's see, 5, 15, 30 over 0. Is that right? If I put in 1, 5, 15, 30 over 0, right? All right, so that means there's going to be a vertical asymptote at x equals 2 and a hole in the graph at x equals 1. There's a vertical asymptote at x equals 2, or -2, sorry. If there's a hole in the graph at 1, how do you find the y coordinate?
There's a hole in there.
0, 0. Oh, okay, I got it mixed up, sorry. What were you going to say? Oh, Ferguson's over here bothered me. Threw me off my game. 0 over 0, hole in the graph. And 1, there we go. 30 over 0. All right, so there's a vertical asymptote. So if it's at -2, the hole in the graph, how do you find the y coordinate? Actually, a hole in the graph is known as removable discontinuity. You actually remove the discontinuous part, and then you put the -2 into the result. So the hole is actually going to be at -2, comma. If you put in -2 and -2 for what's left, you have 4 over -15. That's where the hole is actually going to be at. You just kind of remove that part. That's why it's called removable discontinuity. That's the coordinate for the hole in the graph. We already know the vertical asymptote is at x equals 1. If you plug in -2 for x, -2 plus 4 is 2 times 2 is 4, right? Right. Yeah, you put in, after you cross off the factors, you put -2 in for all the remaining x's. Yeah, then you calculate it out. Also, kind of interesting, what's the degree of the numerator? If I multiply out, now I'm looking at the whole thing again. If I multiply out the leading and the leading and the leading and the leading, what would I get in the numerator? 2x squared plus something, right? And in the denominator, I'd get 5x squared, something, something, something. So what's the degree of the numerator? Degree of the denominator? So I know there's going to be a horizontal asymptote at y equals, well, you just simply divide the leading coefficients. So it's going to be y equals 2 over 5. That is the horizontal asymptote. Sound good? Sounds great. How'd that one go?
So holes are we get 0 to 0.
Yep.
Vertical asymptote between 0 and the bottom.
And then a different number on the top.
And horizontal asymptote is 0 on the top.
No. Horizontal is just by the degree. Okay? We're going to do a, hey, Just out of fun, what is the x-intercept? I know it's not on our checklist of things to do, but just for practice. What is the x-intercept? I could ask somebody in the back, somebody in a white Illinois college shirt. Jared, what's the x-intercept? -4, correct? Can't be -2 because that's a hole in the graph. All right, so this is -4. And then what would be the y-intercept? That's when you put 0 in for the x's. Those are kind of gone. That'd be 8/5. Does that sound right? If I put 0 in for all the x's, find the y-intercept. Yeah, -8/5, right? That would be the y-intercept. Is it negative? Okay, -8/5. Oh, because I look at the numerator and I see what makes it equal 0. Well, -4, if I put in for that x, will make the top equal 0. Okay? Nice. You want to graph it out and see what it looks like?
Yeah.
Let's give it a go. What do you say? I know the directions don't say that, but heck, we're Spartans. We don't back down from anything. Yeah, that's right. No retreat, no surrender. Y equals. Clear it off. Oh, there are some non-believers that forget the parentheses in the denominator. You need one big grouping parentheses for the whole thing. View. There we go. So, y equals 2 parentheses x plus 4 parentheses x plus 5. Oh, sorry. X plus 2. Now I need a big set of parentheses. 5 parentheses x plus 2. Close it. X minus 1. And then a double right. One for the entire denominator, one for the factor x minus 1. Zoom 6. All right, so we got our, let's see, view. Yeah? What? All right. Where do you think the dotted line is right here, where the graph is heading to? Where do you think that line is? That's horizontal. Vertical's up and down. Oh, it's below 1. What do you think it is? 2/5. Then we come up with a horizontal asymptote of 2/5. We sure did. Why is it what? Oh, what's our x-intercept from Jared? -4. Where's our y-intercept? -8/5. Wait a minute, isn't there a hole in the graph? Where's it at? Second, calculate value at -2. Let's see. Ready? What's y equal to? Nothing. Yeah, but I don't see it. Exactly. There's nothing to see. It's a hole in the graph. I don't know. What do you want to see?
Where's the -4 and -6?
-4 is on the x-axis right here. Yeah. And then 8/5, -8/5 is down here.
So is it going across the top?
Yeah, it's going across, hitting the -4 and going down. Now, if you wanted to do something that was really fancy, that's what the calc kids have to do on tomorrow. Well, like I said, their checklist is twice as big, but you get the idea. You draw a graph, -4, -8/5, -2/5. What was our oh, and then 1. So the graph looks something like this. And then it goes right through here, and it crosses, it goes down. So that's kind of what it looks like. Some people are picking their nails. I don't believe it. Nail pickers. All right. Jeez. All right. I like that one. Guess what we're doing? Moving on. I love that. This one gives us the picture. We have to come up with the equation. I know. I'm excited. This is like one of those find the words. Sure it is. So, hey, wait a minute. Who wants to take what part of the graph first? Who knows if there's a vertical asymptote right here at -1, how to put that into our function? Remember, we need a numerator and we need a denominator. Where's it go? The denominator. X plus 1, vertical asymptote. Check. That's one of our little checks, isn't it? What's one of our other checks? Horizontal. It's at -2, right? What? Y equals -2, isn't it? No, that would be for an intercept. That means I take -2 divided by 1. The leading coefficients, right? And there's a hole in the graph. How do I account for that? X minus 4 in the bottom. What goes in the numerator? X minus 4. Why is it what? No, they're the same. They are the same when it comes to the hole in the graph. That's a check. Oh, what's this right here? X-intercept. Where does that go? Numerator. X minus 3. Check. Check, 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 check. Wait a minute. 6. If I put 0 into X, do I get out 6 for Y? I do. Isn't that surprising? I think it is. Have you seen this crew work before? That's amazing. It works. Wait a minute. If you've been in 4, do you really get out -2/5? Zero. Let's see. 4 minus 3 is times -2. Put in 4 down here. 5. Yeah, it works. That's the hole in the graph. Oh, if I put in 0, it should get out 6. And it worked.
So
Yeah?
when you write the equation for the graphs, you always want to leave a point to be able to check it. Is that?
Yeah. You always check it. Nice job. How far do we get?
Number 6.
That's it? We got a lot of work to do tomorrow.
So 1 through. We didn't do 7.
You can know how to do 7. You can do it. 1 through 7 odd on what page?
You got an extra problem. Page 264.
264. 1 through 7 odd.
They were bragging about it to us.
What do you want, 9?
No, they were just bragging about us. We only got through 5 odd.
Yeah, well, they're not too good. All right, so I'm going to shut this off.